Welcome. Today we're going to learn how to solve a system of linear equations by a method called elimination. I've written down the rules and I suggest you write them down as well in your own words or abbreviate them or somehow so you can refer to them as you solve equations. I'm just going to read through them very quickly and then I will walk through the steps as I do some examples. But first, when you're solving a system of linear equations, which by the way is two linear equations, make sure both are written in standard form, where the x terms and the y terms are lined up with the constant. So in other words, the x terms are above each other, the y terms are above each other, and the constant. As an example, very quickly, these are written in the correct form. This is standard form. X term above an x term, y term above a y term, and the constant equal sign. Two linear equations. We're going to solve or find what point those two lines share in common. Again, that's what we're trying to do. Once they're written in standard form or lined up, the next thing you're going to do is determine the least common multiple of the coefficients of the x terms versus the y terms. And then you're going to choose the lesser. What I mean by that is this. On this one here, the coefficient on this x is 3. The coefficient on this x is 1. What is the least common multiple between 1 and 3? Well, the least common multiple is 3. What is the coefficient on the y? It's a 1. What is the coefficient on this y? It's also a 1. What's the least common multiple between 1 and 1? Well, that's 1. We're going to choose to use the y's or eliminate the y's, okay? So we've determined the least common multiple, and we found out it's on the y's, so we're going to eliminate the y's. Now, if necessary, we're going to multiply either one or both equations to get the coefficient on that y value, on the y's, but if it had been the x's, we'd do the x's, but we're dealing with y's. We're going to get the same coefficient on the y's that is that least common multiple, making sure that one is positive and the other is negative. So again, going back up to this equation, if these had been different numbers and the least common multiple we'd found over here was different, I would multiply one or the other. That's already been done. I mean, there's nothing we need to do. They're already the same size and they're already opposite in sign. And we will definitely do another example where we actually have to do something with step 3. But step 3 is done for us because it wasn't necessary. Not done, it just didn't need to be done. Next, step 4, we need to add straight down, in other words, adding like terms to eliminate the one variable that we chose to get the common coefficient. That's here. If we have a coefficient of positive 1 and negative 1, what I'm going to do is I'm just going to draw a line, and just like in elementary school, I'm going to add straight down. I'm going to add the x terms, I'm going to add the y terms, and I'm going to add the constant. And I'm going to keep the equals right where it's at. If I add 3x to x, I get 4x. If I add a positive y to a negative y, it gets eliminated. That's why this process is called the process of elimination. One of the variables gets eliminated. 14 plus a negative 2 will be 12. So now I have a single equation, 4x equal 12. It's actually a one-step equation. And the last two steps are just that. We're going to solve that remaining one-step equation for the variable that's left. Once I know the value of that variable, I'm going to substitute it back in to find the value of the other variable. So as we come up here, I'm going to solve this one-step equation by dividing by 4. That gives me an x value of 3. I know my x value. Now remember, we're solving a system of linear equations that in terms of x and y. That means we have to have points as solutions, not just one number, but a point. Our first x value is 3, the first number. Now we still need to find our y value, and we find that by substituting back in. So let's do the bottom equation. Let's stick this 3 in for that x right there. So I'm going to write it over here. X, which is 3, minus some unknown y equals negative 2. Equals negative 2. I've just written this instead of x, put in a 3. Now let's solve that. I'm going to minus 3 from both sides. That gives me a negative y equals negative 2 minus 3 is negative 5. I need to cancel the negatives or multiply by a negative. I get a y value of 5. So my solution is the point 3, 5. Now again, I'm going to check by going is 3 times 3, because that's what x is. It's 3 times 3, which is 9, plus y, which is 5. Is 9 plus 5 14? It is. Is 3, because that's what x is, minus, what's y? 5. Is 3 minus 5 negative 2? It is. So that is the correct solution. So I'm going to do 2 more now very quickly, and I'm going to go through those steps. So if you need to go back and refer to that, rewind, I would have them written down. But now this one, if you'll notice, the numbers in front of the x's are different. The numbers in front of the y's are different. They're already written in standard form, though. The x terms are lined up, the y terms are lined up, and that third term is lined up. So I need to find the least common multiple between the x's. So the least common multiple between 4 and 8 is what? What's the least common multiple? Well, that's 8. What's the least common multiple between 6 and 9? Least common multiple between 6 and 9, well, that's 18. Right? Which one's smaller? Well, 8's smaller. So what I'm going to do is I'm going to manipulate one, if not both of these equations to get these to be both 8. Well, this one's already 8, so I don't need to manipulate that one. I'm going to just rewrite that one down. 8x plus 9y equals negative 16, because I didn't do anything to this one. But this one I'm going to manipulate. I'm going to multiply both sides of the equation by a 2, which will make that an 8. So, and we can do that because it's an equation. It's the same equation if I multiply both sides of the equation by the same number. So I'm going to go 2 times the negative 4x. That gives me a negative 8x. 2 times the negative 6y. That's going to give me a negative 12y. Equals 2 times the 20 is going to give me a 40. So this new top equation really is the same as this equation. It's just everything's been doubled. Now I'm going to add, because now when I add, the x's will cancel, be eliminated. So sometimes it's the y's, like up here, we had the y's get eliminated. This time, the x is going to be eliminated right off the bat. Those go away. I'm going to be left with a negative 12y plus 9y is a negative 3y equals 40 minus 16, or plus a negative 16, is going to be 24. Now I divide by my negative 3. This is my second to last step. That gives me a y value of negative 8. So I know my y value is negative 8. Now I'm going to plug it back into one of my original equations. So I'm going to plug it in right here. Well, in for y, not x, right here. So I'm going to have an 8x, that's this term, plus 9 times y, but we found y to be what? Negative 8 equals this negative 16. Now let's solve. 8x, 9 times negative 8 will be a minus 72 equals negative 16. I'm going to add 72 to both sides. I'm going to write this up here now. 8x equals, so what's negative 16 plus 72? It is going to be 12 minus 6 is 6. 6 minus 1, 56. Positive. Divide by 8. And I get an x value of, obviously, 7. So I have an x value of 7, and there's my solution. And again, I can check. Negative 4 times 7 will be a negative 28. So that becomes a negative 28. Minus 6 times a negative 8. Well, a negative 6 times a negative 8 is going to be plus 48. Is negative 28 plus 48 20? It is. 8 times my x value of 7. 8 times 7 is going to be 56 again, plus 9 times negative 8. Well, that's going to be a negative 72. Is 56 plus negative 72 negative 16? It is. It worked. Okay, one more. Now, if you'll notice here, 10 and 9 aren't the same. 3 and 8 are not the same. So I look at the two numbers in front of the x, the 10 and the 9, and I go, what's its least common multiple? Well, the least common multiple between 10 and 9 is 90. Then I look at the 3 and the 8, the numbers in front of the y's. What's the least common multiple between 3 and 8? Well, that's only 24. I'm going to go with the 24. But if you'll notice, I'm going to have to multiply both equations. I'm going to have to take the top equation and multiply by 8 to get this to be a 24. Now remember, I'm multiplying every term by 8. That's why it's the same equation. So that top equation will become a negative 80x minus 24y equals a 80 plus 72 is 152. I'm going to multiply the bottom equation by 3 because I want this to be a 24. 3 times 9 is 27. X plus 3 times 8 is 24y equals 3 times 20 is 60. Now, these were already opposite in sign. If they had both been plus, I would have made one of these numbers a negative to make sure it changed sign. Because remember, I want one to be negative, one to be positive. That's one of the steps. Now I'm going to add straight down. The y's are going to cancel. I'm going to be left with negative 80x plus 27x is going to be 53x equals 152 plus 62 is going to be 212. Divide by 53, and we get an x value of 4. Now that I know my x value, I got to find my y value. So I plug back in my 4 into one of my two equations. So I'm going to do the bottom one here. 9 times 4, because that's what x is, plus 8y must equal 20. So again, I'm not using those 3's or 8's. I'm using the original equation. 9 times 4 is 36, plus 8y equals 20. 8y equals, because I'm minusing 36 from both sides, it's going to be a negative 16. Divide by 8, and I get a y value of negative 2. Again, let's check our work. I use this equation to find my y value, so I'm going to check the top equation. What's negative 10 times 4? Well, that would be negative 40. Minus, what's 3 times a negative 2? Well, it's going to be a minus 6, so I actually have negative 40 plus 6. And I do not get 19. So what did I do wrong? Negative, that's 20. 9 times 4, 212, 54, that's 4. 212, yep. 9 times 4 is 36. 20 minus 36, divide by 8. That's going to be negative 2. And guess what? That's my x. No, my x value was 4. So that is my y value. Y value is negative 2. So what did I do wrong? 36 minus 16 is 20. Negative 40 plus 6. It's not 19. Where did I go wrong? 212. That's positive. Right here's where I went wrong. See where I made my mistake? I found my mistake. This is a negative 80 plus 27. This is a negative 53. Negative 53. This is a negative 53. That's a negative 4, not a positive 4. That's why I check my solution. So if that's a negative 4 and I come in here, that's going to be negative. That's going to be a negative 36. So I'm going to add 36 to both sides. Adding 36 to 20 is 56. 56 divided by 8, that's not a negative, by the way. 56 divided by 8, 7. My y value is 7. So I get negative 4, 7. Let's see if that works in the top one. Negative 10 times negative 4 will be a positive 40, minus 3 times 7 is 21, and 40 minus 21 is 19, which is what I was supposed to get. So I've checked my solution, helped me figure out that I dropped my minus sign right here. So don't give up. Check your solutions. If you have questions, please do bring them to class.